Good evening, everyone. So let us start. So the last topic that we have done is ionization energies. We have discussed what are ionization energy, what is IE1, what is IE2. We have discussed all these things. Today we are going to discuss some of the uh, like different oxidation states also we have discussed. Let me show you once. तो अलग अलग ऑक्सीडेशन स्टेट का बारे में हम लोग ने डिस्कस किया था, राइट? We discussed about different oxidation states. For example, scandium, it has +3 oxidation state, which is very stable. Titanium, it has +2, +3, +4. Out of them, +4 is very stable. Why it is very stable, we'll discuss. Then vanadium, it has so many oxidation state, +5 is the most stable. तो एक बात बताया गया था that stability is there due to few reasons. Okay, why a certain oxidation state of a particular element is stable? Okay, কিয় এটা particular oxidation state কিবা এটা এলিমেন্টৰ কাৰণে বেছিকে stable হয় হেতু আমি এতিয়া diagnose কৰিম. Okay, কেনেকে হয় এটো বস্তু কিয় হয় এনেকুৱা. Okay, fine. So the first thing is okay. So the first thing is oxidation state যিকোনো এলিমেন্টৰ যদি stable হয়, there are most probably there are only few reasons. Most elements becomes stable when their oxidation number becomes like when oxidation number makes the element attain D10, D5, D3 configuration. যদি কিবাকে elementor configuration eketa hoye ase, okay, that is D5, D10, D5 and D3. This D10, D5 and D3 কিবাকে যদি এটো configuration hoye ase elementor, তেতিয়া কি হ'ব বস্তুটো বহুত বেছি stable হ'ব. Okay, the electronic configuration will be very stable. How come? Let us see. Okay, for example, let us take any element who has a particular stable oxidation state. For example, manganese or oxidation state যোনটো বহুত stable, that is +2. Normally manganese চাব গলে what is the atomic number? Argon followed by 4s2, then 3d5. Fine, এটো হল configuration. এটা যেতিয়া +2 হৈ গৈ পায় তেতিয়া কি হ'ব, the electron will lose the atom will lose the electron from the higher shell. Okay, baki thakile ki 3d5, ultimately it attains a pure configuration d5. Okay, pure d5 configuration. So this d5, if the configuration is d5, it is very stable. Okay, therefore it becomes manganese easily loses 2 electrons, so the d5 state is attained. It makes the compound very stable. Okay, fine. Let us take one more example. For example, iron. ठीक है, iron और atomic number की 26, argon 4s2, 3d6 हो ऐसे. This is the atomic number and electronic configuration of iron. Suppose, what are the possible oxidation states of iron? Let me show you. This is iron. The most stable oxidation state is +3. ठीक है, iron और सबसे बेसी stable oxidation state की है +3. So let us see +3 हेरी की है, like what is the configuration? Fe, if it becomes +3, then it becomes argon 4s1 হৈ যাব 4s. See how many electrons are lost? 3 electrons. 3 electron হেৰালে no, Fe পৰা Fe plus 3. So it will lose this 2 electron, and 1 out of this 6 electron will also be lost, because total it has to lose 3 electrons. So ultimately configuration to cube of 4s0 3d 5. So it reaches a very happy configuration, that is d5 d10 or d3. So to become this, it becomes very stable. It बहुत बेसी stable hole. Okay, and it requires lower ionization energy. Okay, very stable configuration. Okay, to बहुत बेसी stable configuration है, and requires low ionization energy to reach this state. ठीक है, very stable configuration requires low energy ionization energy. IE means ionization energy to reach this state. क्यों इमान कम energy लगे? Because this configuration makes this 3d 6 into d5. Okay, which makes the compound very stable. Okay, fine. So we have understood one thing, something or the other. Let us take one more example. Ityasabha, there is a further reason of stability. For example, copper. Copper has 2 oxidation number. One is +1, one is +2. A2 basis stable, +2 to basis stable. So you will be baffled by this question. Okay, so the question is, okay, so the point is that copper is argon 4s1 3d10, correct? Copper plus kiman hobo? Argon 4s0 3d10. Okay, so see, it is having direct d10 configuration, very happy configuration. So 4s1 a2 error le tar piche d10 hai aise. So this configuration should not be, this configuration should be very stable, right? Copper plus is very stable, but Cu plus should be very stable. But you can see that Cu plus 1, I have not marked it red. Red marking kora nai plus 1 or upward. Rather than I have marked +2 as the most stable configuration. Enga kyu korlu? Let us see copper +2. Copper +2 configuration to kyu hobo? Ultimately argon 3d9. So copper +2 is 3d9. So ultimately this configuration has came down to 3d9, right? This configuration has came down to 3d9. Fine. So tomar 3d10 or 3d9 go pale. Fine, that is all right. But then why copper +2 is more stable than copper +1? That is the question. Okay, because what we have learned so far, this thing does not match with it. Okay, এতিয়া লোকে জি পঢ়িছো সেই হিচাপতে বস্তুখিনি মিলা নাই. So copper plus has D10 configuration. Copper 2 plus has D9 configuration. Okay, so copper plus is having D10 configuration, copper 2 plus is having D9 configuration. Okay, then why copper D9, this is more stable, this is less stable? What is the reason behind that? এইটো তো আগতে মই কেতিয়াও ডিসকাস কৰা নাই, less stable আৰু এইটো কি হ'ব, this one is copper 2 plus is more stable. What is the reason behind that? Okay, this one is more stable, this one is less stable. What is the reason behind that? The reason is it does not match all these three conditions. মানে এতিয়ালৈকে আমাৰ কি আছিলে configuration? আমি কৈছিলো যে D10 বা D5 বা D3 configuration, এনেকা configuration কি কৰে, makes the compound very very stable. Most elements, not all elements, most elements become stable when oxidation number makes the element attain, when oxidation makes the element attain D10, D5, D3 configuration. ठीक है, तो तुम्हारा copper 2 plus or cathode neither D5, neither D3, neither D10, then why it is more stable? It is because of a completely separate reason. কি হয়, copper directly copper 2 plus হাওয়াত হয়ে না যায়, right? Copper 2 plus, copper is becoming copper 2 plus, it is not becoming copper 2 plus in air itself. Where ionization takes place, here ionization hol no, copper to copper ion bone gol, this ionization takes place in what medium? Definitely in aqueous medium, correct? Copper to plus কেতিয়া হবো, ionize কেতিয়া হয়, পানিত হয় normally. পানির এটো ক্ষমতা আছে that it can convert any element into its ions. So the fourth reason why a configuration becomes very stable is when this copper 2 plus, eto copper 2 plus যেতিয়া পানিত থাকিব তেতিয়া কি হ'ব, let's see. Okay, when the copper 2 plus will be in water, then what shall happen to it? So this copper 2 plus is in water, correct? This copper 2 plus is in water. Now this copper 2 plus is having a lot of positive charge, okay, and lot of water molecules, because it is positive charge, lot of water molecules will try to form bond with the copper 2 plus. Why this oxygen? Because it is having partially negative charge. This oxygen has partially negative charge, so lot of the water molecules is actually forming a bond with this compound. So I can say that this copper ion is becoming hydrated. Okay, this copper ion is becoming hydrated. Okay, this copper ion has become hydrated, right? This any kind of bond formation, mark my words, any kind of bond formation makes a compound more stable. Okay, any kind of bond formation makes the compound more stable. আৰু যেতিয়া এনেকুৱা bond এটা formation হ'ব, bond formation is always exothermic in nature. এটা bond যেতিয়া create হয় কি হ'ব, ultimately energy will be released. Okay, bond forming is exothermic, bond breaking is endothermic. Okay, so eto energy ulabo, this energy which will go out of when this copper 2 plus will form a bond with the water molecule, this is known as heat of hydration. This is known as heat of hydration. Okay, or enthalpy of hydration. কি কয়, enthalpy of hydration. যিমান এনার্জি বাহিৰৰ পিনে ওলাই যাব, কম্পাউন্ডটো ইমানে বেছি স্টেবল হৈ থাকিব. Okay, so this is known as enthalpy of hydration. ठीक है? This is known as enthalpy of hydration. Is it fine? So higher the enthalpy of hydration, jiman besi enthalpy of hydration hobo, iman bostuto stable hoye thakibo. Mane iman energy, jiman energy bahiro pine olabo, more the compound will become stable. Bostuto buji paisa na nai? Please respond.
Yes, sir.
So there is a fourth reason of stability. There are few reasons of stability, like reasons of stability are number one, reasons of stability. The first reason is D10 configuration. Second reason is D5 configuration. Number three is D3 configuration. And number four is hydration enthalpy. Hydration enthalpy. Hydration enthalpy. Okay. This is known as hydration enthalpy. Higher the hydration enthalpy, more will be the stability. Okay. Okay. So reasons of stability of any oxidation state. Okay. Reason of stability of what? Reason of stability of a particular oxidation state. ठीक है? Reasons of stability of a particular oxidation state. इस item. Okay. 1, 2, 3, 4. Okay. So you might answer a question. So let us see, in case of nickel, there is +2. +2 is very stable. Okay. Nickel or carne +2 oxidation state to खूब बेसी stable है. So let us see. See, all these are a stable oxidation state. If you do not have, if you have not written till now, you can take a screenshot of it. Okay, fine. Okay, so question is, nickel 2+ is stable due to A, D5 configuration, B, D10 configuration, C, D3 configuration, or D, that is high hydration enthalpy. Nickel 2+2 इमन stable क्यों है? Why this configuration of nickel 2+ is very stable? What is the possible reason? A, B, C, or D?
Sir, D.
So the answer is, let us see. Okay. Nickel 2+. Nickel or electronic configuration to key argon 4s2 3d8 because 28 atomic number. এতিয়া নিকেল 2+ হলে আর্গন হয় 3d8 হব 4s 4s or দুটা ইলেকট্রন গুচি যাব, these 2 electrons of 4s will be gone. Why? Because 2+ oxidation number ahile. Okay, since this electronic configuration is gone, it has become 3d8. Okay, so okay, so this 3d8, so it does not match d5. Eto match nohol, eto match nohol. Okay, this is not matching, this is not matching. D3 configuration is also not matching. Okay, so because d8 hole, to eto can match over d5, d10, d3 cannot match. The only option left is higher hydration enthalpy. Okay, so the reason for the stability of Ni2+ is higher hydration enthalpy. The reason for stability of Ni2+ is the reason for stability of Ni2+, nickel 2+, is higher hydration enthalpy. Fine, done. So this is the reason why nickel 2+ is very stable. The same reason is applicable for copper 2+ also. Copper 2+ is also very stable due to higher hydration energy. Okay. Fine. There is a question. One more question is there. Let me write it. The question is, vanadium. Okay. Vanadium plus is more stable than vanadium. V plus is more stable than vanadium. Okay, vanadium plus is more stable than vanadium. Okay, or there's a different question to this. Or second ionization energy of vanadium is very high. Second ionization energy of vanadium is very, very high. Fine. So let us come to this question. Okay. So vanadium or ki hoy, yate a special case hoy, special case. Okay. This is a special case. What happens here? So vanadium or normally atomic number hole 23. Okay. Argon 4s2 3d3. Okay. So 3d3. Normally this configuration should be stable. Okay. But V plus is more stable than this also. Why it is so? Because there's a reason, okay, behind that. Not for all the elements, only there's a special case. So I'm talking only about vanadium. Okay, vanadium or karni enekwa hoy. ठीक है? So vanadium or যেতিয়া এটা electron ulai jay, তেতিয়া কি hoy argon. This becomes 4s1 3d3. It remains like that. immediately when V plus oxidation state to hoy ইয়াতে এটা স্পেশাল বস্তু হয় বাকি কোনো এলিমেন্টত এইটো বস্তু নহয় okay when this stage reaches energy alteration takes place okay what is this energy alteration to ki hoy keneke hoy let me show you so vanadium to sab gole it is argon 4s2 3d3 right so it is 4s2 3d3 the pasta 1 2 3 4 5 fine so 4s2 3d3 4s2 s or keta thakibo duta electron thakibo aru 3d keta thakibo eta 3d sorry d keta tinita eta eta electron ulai joar pisot ki hobo when the v it becomes v plus when it becomes v plus again what happens 3 4 5 when this electron is there 1 2 3 3 hoy enika hoy no so eta electron gusi gol so v plus ultimately ki hobo it will become 4 electrons na 4s1 3d 3 4 so it will become 4s1 3d3 okay so 4s1 3d3 it will become 4s1 3d3 v plus about the 4s2 3d3 asle eta 4s1 3d3 immediately the special thing that will take place is this one electron from the s orbital this is the s orbital this is the d orbital correct so this one electron which was left alone from the s orbital it will jump into the vacant orbital of the d orbital vacant d orbital okay when this electron particularly makes this jump then what happens you see the number of possible exchanges shall increase so yate jodi etu enekwa hoy tete ultimately configuration to ki hobo v plus or configuration to ki hoy jay v plus has a totally different type of configuration it will become argon 3d4 so the configuration of v plus should have been 4s1 3d3 but it is actually v plus is argon 3d4 because a eta electron jonto s ot asile this electron had jumped itself into d fine so this is our v plus argon 3d4 so this configuration when it reaches a2 configuration jetia reach kore v plus a2 configuration jetia reach korile tetia tumi swa the exchange energy increases agote ki man asle d tinita eta d keta ase saita right d is 4 okay agote d tinita asile eta s or pora electron gayab 4s0 hol 4s0 gutte keta electron d ahile 1 2 3 4 fine এতিয়া গুটে কেটা d আহিলে যদি you have to find the number of possible exchanges because side electron আছে অকলে অকলে so ইহতে নিজৰ মাজত কি কৰিব they will do the exchanges therefore number of possible exchanges বাঢ়ি যাব no number of possible exchanges will be 4c2 will be equals to 4 times c2 okay or 4c2 so it will be 4 factorial divided by 2 factorial divided by 4 minus 2 factorial fine so 4 factorial to kiman hobo 4 3 2 1 divided by 2 factorial 2 into 1 divided by 4 minus 2 factorial okay so factorial mane এইটো নাম্বাৰৰ তলত যিকেইটা নাম্বাৰ আছে গোটেইকেইটা মাল্টিপ্লাই কৰি দিয়া যেনেকে 4 তলত কি আছে 3 আছে 2 আছে 1 আছে গোটেইকেইটা মাল্টিপ্লাই কৰা যেনেকে if I write 6 factorial then 6 into 5 into 4 into 3 into 2 into 1 Okay, গোটেই number multiply কৰি দিবা. So 4 3 2 1, so it is 2 2, so it will become 4 times 3, 2 factorial given 2 times of 1, 2 2 ja 4, ultimately it is 6. So number of possible exchanges becomes 6. Number of possible exchanges becomes 6. Okay. When it becomes 3d4, the number of possible exchanges becomes 6. Jiman besi possible exchanges hobo, iman besi energy ula to stable hobo. Okay. Had it been only 3, agode tinta asile no, tinta asile. So if it was only 3, then what will happen? Number of possible exchanges কিমান হ'ব? 3c2 চাই লোৱা কিমান হয়? 3 times of 2 times of 1, 2 times of 1 into 3 minus 2 factorial. So এটো কিমান হ'ব? 3 into 2 into 1, 2 into 1 into 3 minus 2 কিমান? 1 only. 1 factorial 1 এ থাকিব. So 2 2 cancel হ'ব, 3 6. ठीक है, done. So this is all about the number of possible exchanges. We are done with this. So you can write this. If you understand, well and good. If you do not understand, still all right. Jiman besi possible exchanges hobo, iman besi energy aibo, iman bostu to stable hobo. Okay. Just remember, if this number is it is bigger number means more stability. Lower number means lower stability. Fine. Okay. So we have done few electronic configuration. Okay. So there is a question. মানে আমার যদি ইলেকট্রনিক কনফিগারেশন বিলাক চোৱা, যিকোনো এলিমেন্টৰ প্ৰত্যেকটা এলিমেন্টৰ ইলেকট্রনিক কনফিগারেশন তুমি চাবা, there is a difference of only 1 2 3 4 5 6 7. ঠিক আছে, এটা এলিমেন্টৰ যোনটো ইলেকট্রনিক অক্সিডেশন স্টেট থাকে, they differ only by the value of 1. কিন্তু যদি তুমি পি ব্লকৰ এলিমেন্টস কেইটা চোৱা, তেতিয়া তোমাৰ ইলেকট্রনিক অক্সিডেশন নাম্বার বিলাক they differ by a amount of 2. Okay, I'm showing you one example. Okay, in D block elements, okay, the element oxidation state differ by a value of 1 unit, such as manganese. Manganese or ক্ষেত্ৰত আমি দেখা পালো already. In case of manganese, it is +2 +3 +4 +5 +6 +7. Like that, in D block elements, the elements oxidation state differ by a value of 1. So what are the possible values? It is +2 +3 +4 +5 +6 +7 and so all they differ by 1. So this is just one case. In D block. Okay. Then in P block, the elements oxidation state differ by a value of 2. I'll show you how. The elements oxidation state differ by a value of 2. Jeneke for chlorine, suppose it is -1, then it is +1, then it is +3, then it is +5, then it is +7. Okay, chlorine shows this many oxidation state. ठीक है? अच्छा, इमान oxidation state, multiple oxidation state क्यों देखा है? What is the reason behind these elements showing multiple oxidation state? Okay, এইবিলাক elements যদিও হয়, why they are able to show multiple oxidation state? The reason is যিমান বেছি unpaired electrons থাকিব elementor ভিতৰত, the number higher the number of unpaired electrons in an element, more will be the number of oxidation state. Okay, so this is a very, very important line. Higher the number of unpaired electrons, higher the number of unpaired electrons, higher will be the oxidation state. ठीक है? Higher the number of unpaired electrons, higher will be the oxidation state. Is it fine? Okay, so যিমান বেছি unpaired electrons থাকিব ইমান বেছি তোমাৰ oxidation state থাকিব elementor. Okay, very important line, so I'm just marking it. Okay, fine. So we have learned many things till now. Next. So where can we observe such oxidation state of the D block elements? Okay, so in few compounds, most of the elements of D block, okay, most of D block elements shows higher oxidation state. Higher mane kya nekwa? +5, +6, +7. Higher oxidation state either in most of the D block element shows higher oxidation state either with fluorine or oxygen in their compounds. Dhruva person, most of the D block elements shows higher oxidation state either with fluorine or oxygen in their compounds. For example, titanium TiO2. Okay, now let us see for titanium. Titanium or kiman oxidation state highest? Ti+4, right? Titanium or karne +4 oxidation state to highest thake. So here we have this compound TiO2. If we determine its oxidation number ki hobo? Jodi titanium or oxidation number to bisara ki hobo? X plus oxygen or hoday -2 e thake equals 0, eko charge nahi, so equal to 0. So x or value to kiman thakibo? X is equal to +4. So titanium is showing a higher oxidation state with oxides. Not only titanium, you will find many cationic oxides of the elements. Cationic oxides mane ki? Cationic oxides mane hol jeneke VO2. Oxygen thakile jikono bostu oxide boli koy. ঠিক আছে, যিকোনো এলিমেন্ট বা মেটালৰ লগত অক্সিজেন থাকিলে এটো অক্সাইড বুলি কয়। Now এটোৰ লগত যদি এটা চাৰ্জ থাকে VO2+, so this is cationic because it has become plus charge. Cationic মানে plus charge আৰু oxide মানে অক্সিজেনৰ লগত কিবা এটা compound বনাইছে। Fine. So what will be the oxidation state? it will become x plus 2 times of minus 2 is equal to x plus this vanadium is x, oxygen always is minus 2. How many oxygen is there? 2 oxygen is there. 2 times of minus 2 is equal to, what is the charge over here? The charge is plus of 1. Charge is plus of 1. So what is the final answer? The final answer is x is equal to plus 1 minus 4 পৰা যদি এটো plus 4 গুচি যায় অক্সিডেশন স্টেট টু কি আহিব plus 5 এ আহে plus 5 এ আহিব so plus 5 is the oxidation state ठीक है fine so titanium is plus 4 and this vanadium will be plus 5 oxidation states is it clear done next is chromate CrO4 2 minus CrO4 2 minus CrO4 2 minus. So what will be CrO4 2 minus? It is x plus 4 times of minus 2 is equal to minus of 2. ठीक है? X chromium to my x ধৰি ললো oxygen সদায় minus 2 থাকে কেটা oxygen আছে 4টা so 4 times of minus 2 is equal to overall charge ji আছে এটো minus 2. So this is anionic oxides you may say like that. Fine. So if you solve it, it will become x equal to plus 6. So you can see most of the highest oxidation states or by any element. Jeneke tumi titanium or plus 4, vanadium or plus 5, chromium or plus 6. Okay? Titanium or plus 4, vanadium or plus 5, chromium or plus 6. They are the higher oxidation states. Most of the higher oxidation states is shown only with oxygen. Okay, particularly with oxygen. Highest oxidation states are particularly shown with oxygen. Highest oxidation states are particularly shown with oxygen. ठीक है जिमान oxidation state higher oxidation state থাকে they are shown by oxygen fine this is good enough ठीक है done all right now there is a small question normally because d block elements bilage multiple oxidation states show করে যেনেকে chromium it shows chromium it shows 6 also it shows 3 also so তোমালোকে এইবিলাক roman numbers use কৰি আছিলা in a chapter known as coordination compounds when you were supposed to write the names of the compounds you were using the roman numerals so when you are using the roman numerals these roman numerals actually depict oxidation state they actually depict the oxidation state roman numerals actually depict the oxidation state okay so this oxidation state okay these roman numerals which are actually depicting the oxidation state they are said to be what they are said to be stock notations stock notations they are said to be stock notations ठीक है good enough so roman numbers They are stop notations. They are showing the oxidation state of a particular element. Now, let us see something more. In the periodic table to Cannicosli, right? Group 6 was there. The first element of group 6 is chromium. Okay. The second is molybdenum. The third is chromium, molybdenum, tungsten. Okay, W, tungsten, the element which is used in the making of filament. Okay. So this tungsten, W, this tungsten, as the element we go down, the heaviness of the element increases. This is the lighter element of group D, group 6, and this is the heavier element of group 6. This is the heavier element of group 6. This is the lighter element of group 6. Okay. This also shows 6. This can also show 6 oxidation state. Can also show 6 oxidation states. Okay. Correct. So chromium in higher oxidation state, there is a particular thing that happens. Why I'm showing with chromium, I'll tell you. Okay. Jodio chromium 6, tungsten 6, when the element becomes heavier, the compound becomes more stable at higher oxidation state. Means tungsten is more comfortable with +6 than chromium. Chromium at +6 becomes reactive. ক্রোমিয়ামের উপর যেতিয়া +6 চার্জ থাকিব ক্রোমিয়াম রিঅ্যাক্টিভ হ'ব টাংস্টেনৰ উপর যেতিয়া +6 চার্জ থাকিব টাংস্টেনটো ইমান ৰিঅ্যাক্টিভ নহয় ঠিক আছে so down the group the heavier elements when it shows higher oxidation states they are more comfortable they are more stable in that oxidation state ठीक है but lighter element of a particular group when it shows higher oxidation state they are not very stable that means they are more reactive ठीक है so what I'm going to write is a simple note chromium shows 6 tungsten also shows 6 both are elements of group 6 this is the lighter element this is a heavier element okay the heavier element is more stable at higher oxidation states okay যেতিয়া মই stable word to use koro the meaning of this word stable is non reactive okay it means non reactive okay to beleg bhabe to heri nokoriba mane perceive nokoriba when I say stable that means it is more less reactive that means it is going to stay okay something which is very reactive is going to change something which is more stable is going to stay not going to change so easily okay fine this parts are easy only this is not very difficult fine okay next there's a question based on this Cr +6 or you may write chromium 6 is a stronger oxidizing agent than tungsten 6. Okay. Cr6 is a stronger oxidizing agent than tungsten 6. W means tungsten. What is the possible reason for it? Explain. Can क्यों है नेगवा? Okay. Simple reason. Chromium, if it is +6, तुम्हें स्वाया था उसको. Oxidizing agent, যদি এটা oxidizing agent হয়, that means Cr+6 reduces itself. Okay. Oxidizing agent or মানেই হল এটো নিজক কি কৰিব reduce কৰি লব. Cr+6 reduces itself. ठीक है. Chromium+6 reduces itself. Fine. So Cr+6 actually reduces itself, and tungsten 6. Okay, we'll talk about tungsten 6 later. Cr+6 reduces itself. Okay, reduces money ki it means good oxidizing agent. That is good oxidizing agent. Okay, that means it is good oxidizing agent. So Chromium+6 would like to gain electrons because it is very hungry right now. Bhook lagi se wo, because it has not eaten anything for 6 days, something like that. Okay, Chromium+6 has lack of deficiency of electrons. So if it gains electrons, suppose Cr+6, if it gains electrons, then it would definitely like to attain the next stable oxidation state, that is +3. Chromium+6 যদি electrons gain করে লয়, because chromium is there, it is having +6. If it attains electrons, if it gains electrons, then definitely it would like to become +3 than any other oxidation state. +6 or +3 হব বিচাৰিব, because it was stable. যদি +6 যদি electrons gain করে, at least it will try to become +3. Okay. So whenever the reaction based on chromium will be there, you can match the oxidation states. Okay, you can match the oxidation states of both sides. It attains one stable state to the other stable state. So Chromium+6 will gain 3 electrons to form Cr3+. That's all. It will form some Cr3+ based compound. Okay. Okay. This is also stable oxidation state. This is also stable oxidation state. However, tungsten 6 is less reactive and do not gain electrons, okay, easily. There is 2 reasons. Okay, what is the 2 reasons don't get electron easily? Why tungsten do not gain electrons easily, though it has the same set of oxidation states? Chromium or if chromium has +1 +2 +3 +4 +5 +6 oxidation state, then tungsten also has +1 +2 +3 +4 +5 and +6 oxidation state. Both the elements are having the same oxidation state. In fact, the elements which is in the same group of the D block has the same type of oxidation state. Fine. So why chromium is more interested to gain electrons to become +3 and why tungsten is not doing it? There is 2 reasons. 2 reasons for stability. stability, right? Two reasons for stability are tungsten is a heavier element. Heavier means like you can understand it is more experienced. Tungsten is a heavier element. It is down the group. Down the group hole ki hoy metallic character increase ho jaye. Okay. Since down the group metallic character increases. So metallic character jodi bahi jaye, it becomes very difficult for the metal to lose electrons. Down the group metallic character of W is greater than chromium. ठीक है टंगस्टन और हेरी टू बेसी है स्टेबिलिटी टू बेसी because it is more metallic in nature, therefore it loses electrons easily. Number 2, okay, it is heavier element also, that is one of the important part. Size of atom, size of atom is vast, very big. Size of atom is okay, is higher. All right, fine, so this will do. Next, so what we get the conclusion that why chromium plus 6 is a stronger oxidizing agent, because it's a lighter element and tungsten is a heavier element, that's all. Okay, so this reason is the enough. It reason likhi disilu je heavier element is more stable at higher oxidation state, so this reason is enough. Fine, okay, next. Organometallic compounds. Organometallic compounds, what are organometallic compounds? There are some compounds like there's some metallic compounds like NiCO4. Your question came, right? NiCO4, you had to tell the type of hybridization, then magnetic property, then type of complex, so many things you have, spin of complex, so you have to find out so many things, right? But yate ki hoy nickel and CO4, this is known as organometallic compound because there is two different bonds. There is two different bond between nickel and carbonyl. CO means not cobalt, carbonyl. Okay, there is two different bond between nickel and carbonyl. What are the two different bonds? Number 1 is the sigma bond and number 2 is the pi bond. So tumhe bhaba, metal also creates pi bonds with this carbonyl compound. Okay, not only NiCO4, in same there is one more compound which is very similar to this, and these are FeCO5, same to same. Here also iron forms two different bonds with carbonyl. One is the sigma bond, one is the pi bond. Okay, let me show you how the sigma and pi bond are created. Sigma bond to jana hai. Sigma bond is formed by coordinate covalent bond. These are coordinate covalent bond. Coordinate covalent bond where a lone pair where a lone pair is donated to the central metal atom central metal atom to form sigma bond. ठीक है, to form sigma bond. ठीक है, sigma bond formation और कारणे कार মাজত হয় lone pair of ligand plus okay lone pair lb মানে কি lb মানে হল lone pair of ligand plus vacant d orbital lone pair of ligand plus vacant d orbital. This is the sigma bond. Okay, lone pair of ligand vacant d of orbital দুটা একেলগে আহিব bond creation কৰিব. Okay, fine. The question is how pi bond is formed. Let us see how pi bond is created between central metal atom and ligand. Okay, sigma bond বুঝি পালো আমি because that is the first bond which is created. To know this pi bond to কেনেকে create হয়, we have to go back to class 11, like not physically but in our mind we have to go there. There was a chapter known as chemical bonding, and in that chapter we had learned something called the molecular orbital diagram. So from that molecular orbital diagram we are going to find out how this is actually created. Okay, so let us go and find out. Okay, so this is the molecular orbital diagram. This arrow represents energy bar. These are energy bar তলত থাকিব because we are making for carbonyl na, carbonyl is CO, carbonyl is CO. So একফালে কি হবো, it will be atoms of carbon, atom of carbon, atom of carbon, আৰু একফালে কি থাকিব, আৰু একফালে থাকিব atom of oxygen. ঠিক আছে, atom of carbon, atom of oxygen, দুইটাৰ মাজতে কি হব, molecule of carbon monoxide, CO, molecule of carbon monoxide. So একফালে carbon থাকিব একফালে oxygen থাকিব, দুইটা মিলালে কি হব, it will form carbon monoxide. So how is the configuration of carbon? It is 1s2. Okay, 1s2. Oxygen কি হব, oxygen will also be 1s2. ঠিক আছে, 1s2 এই দুটাৰ পৰা কি আহিব, এই দুটাৰ পৰা এটা নতুন অৰবিটেল আহিব. These are known as the molecular orbital. This is the first, this is the second. তলৰ থকা orbitals কেটা বেছি stable, ওপৰ থকা orbitals কেটা কম stable, because তলৰ থকা orbital টোৰ নাম হল bonding molecular orbital. This is the reason why two atoms are together. This is simply, we can write here sigma bond. Okay, sigma 1s. Okay, sigma 1s, sigma because first is the sigma bond, second is the this is the orbital which has more energy. This is the reason why a molecule may break down ABMO. Whenever two persons are there, there is a reason for bonding and there is a reason for separation. Okay. So if this is having more weightage, then this small reasons won't matter. Okay. So sigma 1s, this will be also sigma star. Why there is a star? Because it represents higher energy. Sigma star 1s. ऊपर 2. ठीक है. Similarly, there is 2s, sigma 2s. There is 2s orbital. And similarly here also there is 2s orbital of the, one is carbon, one is the oxygen. Okay. So it is 2s kiman thake carbon, 1s2, 2s2, 2p2, right? And this will be 2s2. Yato eta eneko box ahibo, which is the bonding molecular orbital sigma 2s. And yate eta box ahibo, that will be sigma star 2s. Fine. ठीक है, done. Next, অকমান ওপৰত যাওঁ, energy level আমি ওপৰত গৈ আছো. We are going up in the energy level. Then is after 2s comes 2p. After 2s comes 2p. 2p কিমান হ'ব? 2p কাৰ্বনৰ থাকে 2p2. Because atomic number is 6, so 2 2 2 2p2. Here also it will be okay, it will be 2p what? 2p4. For oxygen it is 1s2 2s2 2p4. Fine. So yate ki hobo? Because there is oxygen in it, so it will be 2 1 2 1. Okay. Sorry. 2 1 2 1 no, 1 2 2 1. ভুলে সৰুকে আঁকি দিওঁ 1 2 2 এটা 1 থাকিব. Okay, done. So fine, this is ठीक है. So let us fill up the electrons. Carbon or केटा electron আছে? Carbon or total electron আছে, because atomic number is 6 only. 1 2 3 4 5 6 total electron. ठीक है. Whereas atoms of oxygen केटा electron আছে? Atoms of oxygen has total of 8 electrons. 1 2 3 4 5 6 7 8. Fine. So তুমি চোৱা এটোৰ নাম কি? This was sigma star 2s. This will be sigma তলৰটো sigma 2pz. ওপৰটো কি হ'ব? pi 2px. This will be pi 2py. This will be pi star 2px. And this will be pi star 2py. Okay. Pi star 2px, pi star 2py. Okay, I'm writing it very small. Okay. So next up will be sigma star 2pz. ठीक है. So electron bila kenike fill up hobo? Yabra eta, right? So carbon or eta electron ahibo. Carbon or eta electron ahile. Then oxygen or eta electron ahibo. Then next carbon or eta electron ahibo yate, oxygen or eta electron ahibo. Like that, both the electrons will start filling up the molecular orbital until there is no more electron. So next is eta ronga ahibo yapra. The electrons are coming from the left as well as the right. So it will become the electron, one electron one electron will jump from here to here. Okay. Are at electron? Yeah, right? It will come from here. Okay, duta electron ahile. Similarly, total how many electrons were there? 1, 2, 3, 4, 5, 6. Total 6 electrons. Duta electron fill up korilo. Baki ahib on next red, then orange from here. Then again red will come. Red dutai asile, red fill up hoibo. Etia orange keta gutekini fill up koriba. 2, 3, 4. 1 total keta hol 2, 4, 6. 2, 4, 6. So electrons fill up hoibo. So ultimately tumi ki sabo parisa that pi star, this orbital is the empty orbital, vacant orbital, right? Yate ekoi nai, vacant orbital. Yate eko nai, vacant orbital. Vacant orbital. ठीक है? So কি হয় metals or lone pair কেইটামান থাকে. Okay, metals have lot of lone pairs. This lone pairs and this vacant anti-bonding orbitals, pi star orbitals, they combine to form pi bonds. Okay. Ako কৈ aso metals or lone pair থাকে. For example, I'll just write one of the metals right now. I'll just write one of the metals right now. So for example, there is nickel. ठीक है? Nickel কারণে কি হবো? Nickel is argon 4s2 3d 8. ठीक है? So just drawing this 3d orbitals. 3d কারণে কি হবো? 1 2 3 4 5. ठीक है? So how many electrons are there in this d orbital? There are 8 electrons. There are total of 8 electrons. So what will happen? 1 2 3 4 5 6 7 8. So there are 8 electrons in this nickel 3d orbital. Okay. So yate jeketa lone pair ase no, like this lone pairs are there. This lone pairs of metal, this lone pairs of metal and this vacant orbitals of carbonyl CO group, they actually overlap. The lone pair of metals and the vacant orbitals, vacant anti-bonding orbitals, lone pair of metals and vacant anti-bonding orbitals overlap. As a result, what happens? As a result, there is a overlapping, there is a bond formation, and this is the pi bond. Okay. So sigma bond to belag or pi bond to belag. Okay. So I'll write this. Very important. Lone pair of d orbital of metal and vacant anti-bonding orbital, lone pair of d orbital of metal and vacant anti-bonding orbital, lone pair of d orbital of a metal and vacant anti-bonding orbital of carbonyl CO. This is the ligand. Okay, this is the ligand. तो की है हमारा ligand. ठीक है? Anti-bonding orbital of CO. Lone pair of d orbital and vacant anti-bonding orbital of CO overlaps to form pi bonding. ठीक है? Fine. So pi bond to কেনেকা creation hall আৰু sigma bond to কেনেকা creation hall এটো বস্তু মই clear কে কৈ দিলো. Okay. So there should not be any kind of confusion regarding this. Next. So we have done many things today regarding the ionization energy, then oxidation state. Okay. All right. So these are fine. Now there is a special thing because we have done the chapter of electrochemistry. Now you will understand these things. Okay. Friends, in m plus 2m E naught values. E naught values are meaning to keep. E naught values are meaning whole. The meaning of E naught value is SRP value. This is known as the standard reduction potential value. Fine. Standard reduction. Standard reduction potential value. Okay. So what we have seen that m plus 2 trends in like you will see what we are going to see now. M plus 2 to m plus 2 to m mane ki m plus 2 is gaining electrons to become m, and for doing this there will be a certain E naught value. What is this naught? We have already known this naught means standard conditions. Not to mane whole standard conditions. ठीक है. So standard condition हिसाब होते हैं. What is the temperature? The temperature is 25 degrees Celsius, 1 atm pressure, concentration should be 1 mole per liter in the electrolyte. Okay, these are the standard conditions. So E naught values will tell you, the trend in the E naught values will tell you a different story. Let's see. Okay, for example, suppose this is the format. This is the format, m plus 2 to 2 electron, it is getting m. Okay, for example, scandium is there, element scandium is there. Okay, scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, copper, and cuprum. Actually, nickel, copper, and zinc. These elements are there. Fine. These are the different elements. Now, go take it E naught values. E naught values for m plus 2 to m. Mane m plus 2 to m hobole. Duta electron gain koribo. So, eitor values are gom pai jaba. Tar kenekwa avastha. Okay. So, for example, scandium or garnet, it is not known. For titanium, it is minus 1.63 volt. For vanadium, it is minus 1.18 volt. For chromium, it is minus 0.9 volt. For manganese, it is minus 1.18 volt. For iron, it is minus 0.44 volt. Okay. Cobalt, sorry, iron, it is minus 0.44 volt. Cobalt, it is minus 0.28 volt. For nickel, it is minus 0.25 volt. For copper, it is plus 0.34 volt. And zinc, it is again minus 0.76 volt. Okay. Okay, now see volt. So in case of copper, it is plus. Baki gute getaswa, they are all minus. they are all minus. তার মানে কি negative sign, what does it suggest? গোটেইখিনি টাইটেনিয়াম সোয়াইটো minus, vanadium minus, chromium minus, গোটেইখিনি minus. Just one element is plus. Okay, that means that rest all the elements, whenever suppose m plus 2 I write, plus 2 electrons likhilu, it will give you m. এটোর কারণে e not m plus 2 to কি বনিলে m বনিলে. If I give something in negative, যদি মই কেতিয়াবা negative দি দিও, that means that this reaction is not prone to happen. There is a less possibility that this reaction will take place. Okay, negative there মানে low possibility of reaction. Low possibility of reaction. There is a low possibility of reaction. মানে যেনেকা লিখা আছে তেনেকুৱা উল্টাটো আকৌ হৈ যাব. Okay, because it is negative, e not যেতিয়ালৈকে positive নহয় reaction to exactly যেনেকা লিখা আছে তেনেকুৱা নহয়. Okay, if the reaction has to take place the way it is written, then the value of e naught must be a positive value. Fine. Then the value of e naught must be a positive value. In case of copper, we can see that copper plus, it is plus, right? Plus 0.34. So we had already seen this value of copper in the chapter electrochemistry, Daniel cell koriasilo. Etia ami dekha palo bostuto. So copper means copper plus 2, it is prone to gain electrons to become copper. So for e naught value it is plus 0.34 volt. Tar mane reaction to jenega likha ase because etor value plus aile no, plus aha mane reaction to jenega likha ase, that is correct reaction. Okay, means reaction to NAY hobo. Copper is prone to gain electrons. Copper is prone to gain electrons. Jodi gain kore electrons, jodi gain kore, gain of electrons is what? Gain of electrons is reduction. So copper nijor ki kori ase? Reduction kori ase. Tene hole beleg eta atomor ki koribo? Oxidation koribo, because eto electron kune dibo নহলে. This electron is coming from another element na, who got oxidized because of whom? Because of copper. Correct. So ultimately, that means that it suggests copper plus 2 is a strong oxidizing agent because it would self reduction both hungale kori di, because of its ability to reduce itself quickly. Baki keta element or negative hoye ase na, baki keta element or negative hoye ase, they are not interested in gaining electrons. They are metals. Why should they gain electrons? They are metals. Metal or pehchan to gain. Like what is the identity of a metal? It is electropositive. It gives electrons, not take electrons. Non-metals take electrons. Metals will like electrons no. So it suggests copper plus 2 is a strong oxidizing agent. So fine for today. So we'll stop here. If there is any question, one more class, I think, and it will be over, DNF law. So if there is any question, then you can ask, or else we can stop the class. Okay, fine. Thursday we will do again an online class. So be ready. So we'll do a longer class that day. We'll try to finish this chapter. Okay, done. Thank you, everyone.